Hey, all you cool cats and kittens out there. Miss Madrano here with another lesson for Zoom University. Welcome. If you haven't done so already, please take out a pen and pencil and a scratch sheet of paper, and we'll go ahead and continue our logarithm notes from Monday. Alrighty, guys. So now I can break character here. So on Monday, we went over this log property, right? Where if we are taking the sum of two logs with the same base, then we can write it as a single log, where the inputs are now, where we're taking the product of the inputs. So now, this time, we're going to talk about what we can do with our log if we're taking the difference of two logs with the same base. Okay, so this rule is basically saying that if I'm subtracting two logs and they have the same base, I can rewrite it and condense it so that it looks like this. This rule also works if I'm trying to expand that log. So we're going to follow a similar structure to what we did before. And so, my tablet is stuck. Yikes. Okay, cool. So let's go over these first four problems here. So I've got log of 2/3. So remember, this has no base written, so that means the base is 10. So I'm going to write it, if I'm trying to expand it, I'm going to write two logs. Now the input for that first one is going to be the numerator. So log 2 minus log 3. Okay, the numerator always goes first when you are expanding it. Your denominator goes second. All right, so this rule also works for natural log. So if I've got natural log of 5, because that's in the numerator, I can do natural log of 5 minus natural log of x. Okay. Now this would be helpful. The reason this rule exists and how it'll help us is if we are trying to solve for x, like so, it makes it more convenient if we're able to expand it so that we can start isolating that variable. Okay, so for number 3, same thing. I'm going to take log, but this one has a base 7, so I'm going to write 7 there. The first one's going to be 11 because that's in the numerator, minus log base 7. And now what I'm going to write inside parentheses here is everything that's in the denominator. So x minus 1 is your whole denominator, so that whole thing is going to go into that second log. And that's it. That's the expanded version. Okay, so now for number 4, same thing. We write log base 8 of 11 minus log base 8 of 13, and that's my expanded form for number 4. Alrighty, guys, so now we've expanded. Now let's go the other way. Let's try condensing, okay? So this time I've got log of 2 minus log of 20. So if I'm trying to write it as a single log, the one that's first, the input that's first is 2. So that's going to go in my numerator. 20 is going to go in my denominator. And then I can simplify. So that becomes log. 2 over 20 is another way of saying 1/10. Okay. And then if we actually look at this log, we know that we can actually evaluate it. So that log has a base of 10. Another way to ask this question is 10 to what power gets us 1 over 10? And the answer to that is -1. Okay, so once you condense it, sometimes you can evaluate it, and when you can, I suggest that you do. Okay, so now let's look at number 6. I've got log base 9 of 18 minus log of x. And if I try to condense this one, I find that I actually cannot condense. Does anyone, I think I'm back in my classroom. Does anyone know why? And no one's going to answer. Cannot condense. Now, we can't condense this because ... If you said because these logs have different bases, then you are absolutely correct. Okay, again, this rule only works if your logs have the same base. So that first log has a base of 9, that second log has a base of 10. We cannot condense because the bases are different. Okay, let's try number 7. So natural log 6. So 6 is going to go in my numerator, and then in your denominator is going to go everything that's inside parentheses in that second natural log written there. So that's x plus 1. And now you've condensed your natural log. All right, let's look at number 8. So first thing I want to do is make sure that both logs have the same base, and they do. So now I can start condensing it. So log base 4, 5 is going to go in your numerator. 20 is going to go in your denominator, and we can simplify that fraction so it becomes log base 4 of 1/4. And guess what? We can evaluate that. The answer to this one is also going to be -1. All right, guys. So now it's time for you guys to practice on your own. So on your own, I want you guys to expand the following. Copy this down on your paper and hit pause on the video. All right, welcome back. So now I'm just going to show you the solutions to these. Here are the solutions to the problems that you just did. Okay, compare your answers. Alrighty, guys. So for number 1, when we expand it, we get this one for your second log. So we get log of 10, which simplifies down to just 1. So log of 10 is another way of writing 1. Okay, and then when you expand number 3, we get log base 2 of 16. And so we know that log base 2 of 16 is 4. So that's where that 4 comes from. Okay, so now let's practice going the other way, condensing. So again, hit pause on this video, copy down the problems. All right, guys, welcome back. So now we're going to go over the solutions. Here are the solutions to those 3 problems in the work shown. So when we condense this one, we get 1/10, which is very similar and actually the exact same thing that we did before. We can evaluate that. That's going to get you -1. For number 2, when we condense it, we get this answer. And then for number 3, when we condense that, we get log 2 of 36. And when we evaluate that, we get our answer is 5. Alrighty, guys, so that's all I have for you today. Don't forget to like, subscribe, and leave a comment down below. If you have any questions, feel free to send your teacher an email or attend their Zoom office hours. See you in the next one. Hey, all you cool cat. Bleh. Take 2. Hey, all you cool kids. Let's try this again. I can't remember how she started. Okay, you know what? Let's just move on. I tried to